Okay, so let's see the question first. So given is T is equal to 6.8 AB8 dollars. Okay, so if A and B denote the 100 and the 1000 digit respectively of the sum of money T, what are the values of A and B? So there are two statements given and we need to figure out if we can find the solution of this problem using any one of these statements or using both the statements together, or whether at all we'll be able to find a solution or not. Okay, so before moving forward, so this is a typical question of data sufficiency. So before moving forward, let us first understand what is rounding of decimals. Okay, so rounding is nothing but a simplification or approximation of numbers. Okay, so let us take a simple example first and then we will understand how rounding of decimal happens. Let us take an example 2.3467. Okay, so we know that this is the decimal, so the digit to the right of this decimal is the 10th position, or I can write it as 1 by 10th. This digit 4 corresponds to the 100th position. Okay, and digit 6 corresponds to the 1000th position, and so on. So let us try to, and in the question it's written nearest cent, so cent is nothing but the 100th position. Okay, now let us try to figure out how do we do rounding of decimals. Okay, so let us take this question 2.3467. let us try to round it off till the cent position. So cent position is this, or the 100th position. So I'll draw a simple wall segregating the cent position and the positions which are to the right of it. Now the fundamental principle of rounding states that the wall that has been created by me, that this corresponds to the cent position which I need to round off, I will check to the right of this digit, the one that I have circled, which is 6. So if this digit to the right of 4 is greater than equal to 5 or less than 5, depending on this we will be approximating it. For example, in this particular case the digit is 6, which is more than 5, so the approximation will become 2.35. so basically I have to add one unit to this number 4. Okay, now had this number been suppose 2.3437, and I would have been rounding to the cent position or the 100th position as in the previous case, I see that the digit to the right is 3, which is less than 5, so the approximated number will become simply 2.34. I need not add 1 unit to this decimal. Okay, so the approximation becomes 2.34. So let us go back to the question now and try to figure out how we can solve it. Okay, so what is given is T is equal to 6.8 AB8. So let me try using the first statement first. So T is 6.8 AB8. The statement states that the statement is if T were rounded to the nearest cent. So what is a cent? This is cent. so this is rounded to the nearest cent or the hundredths position. The result would be 6.85. This means that, so what are the various possibilities, what are the various values that A and B can take? We need to figure it out. Now if we see closely, we know that if A is 5 and this is B and this is 8 and B value is less than 5, then on approximation, if this value is less than 5, then on approximation the value of A will remain same, which is 6.85. Now suppose B is greater than equal to 5, then what could be the possible value of A? So the A possible, since if we know that if B is greater than equal to 5, then A has to be less by 1 unit, which is 4. So if B is greater than equal to 5, so this on approximation becomes, this digit becomes 5. So again the approximation becomes 6.85. This is as it is. Okay. So here A can assume two values. It can either be 4 or it can be 5. And B also has multiple values. So we cannot for sure arrive at the exact solution of A and B. So let us now read the second statement and try to figure it out if we can solve it using the second statement alone. So what does the second statement says? If t were rounded to the nearest tenth of a cent, the result would be 6.85. So which means that tenth of a cent is what? This is cent. This is tenth of a cent. So this is the rounding off that is taking place. And on rounding off, we get 6.85. Since rounding off is still the tenth of a cent, we can write here 0. Okay. So we know that on rounding, this is cent and this is tenth of a cent. This is tenth of cent. Now we know that. Let us try to explore what are the possible values of A and B. So I know that now these are the 3 digits. Now let us go by the very simple thing. Let us look at the digit which is to the right of this wall that I have made. So this digit is greater than equal to 5. It means that there would be an addition of 1 unit when I'll be trying to approximate. So it means that for B to appear as 0, the value of B should be 9. Okay, since it is 8, so if I approximate, I will add 1, so it becomes 0, and 1 gets transferred to A, so A has to be 4, because if A is 4, this 9 on approximation becomes 0 because I add 1 unit and 1 carryover gets over here, and this becomes 5. So this becomes 6.850, which is the required answer. So from this statement alone, I can find out the value of A, which is 4, and the value of B, which is 9. So statement 2 is sufficient enough for finding the solution. Okay. So statement 2, using statement 2 I can find the solution, but using statement 1 I cannot find the solution.